Right, hello everybody, welcome to the stream. Today we will continue developing our game. So let's compile first and then let's see where we left off from yesterday. Okay, I seem to have some frame rate issues here again. So yesterday I worked on updating the hero sprites, so some of the animations are already playing, but not all of them. Right now the frame rate is better, so Chrome for some reason, having Chrome open slows down the game for some reason. It's probably because of I guess I don't have enough RAM. Oh, that's fine. So today I'm gonna work on animations. Currently I'm only displaying the first frame of each animation, so they are just static. It's most visible when walking, so only the first walking frame is being shown, as you can see. So let's start by adding a new field to the collidable component. Currently it stopped being a collidable component a long time ago, but I don't have any reason to split this into multiple components yet, since I don't even know if I need them separately at this point. So let's have an animation speed and current frame. Yeah, I think that makes sense. So when adding the collidable component, I need to initialize the animation speed to 1. So that's the default value for the animation speed. Current frame can stay at 0. And then when I'm processing the collidables, we can just do this. Current frame plus equals animation speed times delta time. Yeah, I think that makes sense. And when rendering, so this is an array of all the frames in the animation, and then the current frame is the entry current frame truncated to an integer modulo frame size. I think that's fine. The animation speed's way too fast. So if the game is running at 60 FPS, every frame I'm basically switching to the next frame. So the animation speed needs to be lower. Yeah, this seems a lot more reasonable. So the idle animation is a little bit too fast. The walking animation is fine. So one other thing I could do is, so currently I don't have a concept of animations. I'm just looping through all the frames. So each frame has the same duration currently. So to make a specific frame longer, make it appear on the screen longer, I would have to duplicate the frame. But instead I could also introduce a new field here that tells me how long this frame is supposed to stay on. Yeah, but then doing it that way makes defining these voxel collections a pain in the ass. The way I'm doing it currently, which is using this editor. So this editor is supposed to only create an atlas. Like this. So it doesn't have animation capabilities. I'm just defining the frames that belong to an animation, but I'm not animating anything. If I do durations here, I could do it, or I could write a separate animation editor. that has a timeline, proper timeline, and I can do more complicated things like switching back and forth between 2 frames before switching to the third frame, for instance, which I couldn't do with just something like this. Okay, is that something that needs to be done now? Because I'm not yet done implementing all the animations actually. There are a bunch of them missing. Like the turning animation. So let's do them first. So what am I missing? I do have the idle, the walk, jump, rising, falling, wall slide. I don't have any of the shooting variants because I can't shoot yet. So I guess I'm missing the turning and landing animations. So let's do them first. One other thing I'm not doing is I'm never resetting the current frame, which I also should do. And to be able to do that, I need to track the current animation. So whenever we switch animations, we want to begin from the first frame. I'm pretty sure I don't have this operator defined. Yeah. I just wrote it. Oh, that's why. Yeah. Results in array, and I'm comparing that to a range. Need to get the range. do this instead of getting the animation frames directly. So I'm just defining the range that I'm using. Or I guess instead of saying range, let's call it animation. It's more explicit what that range is representing. It's supposed to be collidable. No, collection. Yeah. So now, whenever I start walking, I'm displaying the first frame of the walking animation. Hi, Fesek. Okay, that's fine. Okay, now for the landing animation. So if we are grounded, we want to first check if the collidable component so I have a timer for the spatial state here. It tells me how long we have been in the current state. So it tells me how long we've been in this particular spatial state. The spatial state is defined here. So there are three currently. There's the grounded state, the falling off state, and the airborne state. Falling off means we just fell off a tile. It's the state where we can still jump even though we are technically airborne. And what we want to check is so we know we are grounded. We are checking whether we are grounded here. And if the spatial state timer is less than 2 frames, we want to use the landing frames, landing animation. Yeah, 2 frames are way too little. Let's say 20 frames. It's kind of working, although it's staying on longer than expected. So that's supposed to be faster. But the animation speed is too low for that to be faster. So it would be better to have proper animations here. So if I reduce this to 10 frames, it's only gonna show up the first landing frame. So it's never switching to the second landing frame, yeah. But this is more in line with how the landing is supposed to look like. I could cheat a little bit here and I could double the animation speed here. Yeah, now it's showing up the second landing frame, which is just the hair getting back up. I guess for now it's okay to leave it like this. So now next is the turning animation. So for the turning animation, how do I know when to turn? I would have to store the old face direction. Let's try it out like this. So the problem with this is it's only gonna show up the turning animation for a single frame. So I would have to lock the animation. Let's say for 10 frames. Idle, current animation. And we're only gonna change the current animation if the animation lock timer expired, which we set only if we are turning. Although we need to clear it if the collidable isn't grounded. Okay, I'm never counting down the timer. It's showing the wrong turning frame. But that's the problem of the animation actually. Of the sprite itself. This guy. Okay, what's going on there? Did I mess something up? Oh yeah, of course. I need to also update the voxel grid. Yeah, this is the thing that's messed up now. Okay, now it's correct. Right. It's staying up too long. Yeah, this is looking nice. Yeah, I think I'm pretty happy with the animations. One thing I wanted to change is at some point I'm gonna add particle effects, like dust effects when I'm landing or when I'm wall sliding. But before I do that, actually, I want the wall sliding speed to be lower than the regular falling speed. So this movement speed is too fast. I don't know whether I want to make that friction based or whether I just want to set maximum speeds. if I do it friction based, I can add different types of walls that are more slippery or less slippery. Let's try it friction based. First thing, before I do the wall slide friction, I also want to add air friction. That should fix the problem of the player's speed going out of hand if it's falling for a long time, like now. Adding air friction is basically like limiting the maximum speed that the player can fall in the air. Not quite sure what the default value should be for that. Let's leave it at 0 in the default case. Basically like this. And this doesn't need to be dependent on the delta time because you're only doing this on the frame boundary. Is it actually correct? Yeah, because frame boundaries are always happening since we are targeting 60 frames per second, so it's actually frame rate independent in that sense. So let's see. Oh yeah, the coefficient is 0 currently. I need to set it to something different for the player. And player friction coefficient, let's say 0.1. That's kind of a lot, I think. Yeah, now I can't even jump that high. But as you can see, the friction limits my falling speed. I can't exceed this falling speed now. That's how friction basically works. Even in real time, in real life, kinda. But that amount is too high. Let's try this amount. Yeah, this seems nicer. But now I can't go over 2 tiles with a single jump, which means I need to increase the jumping speed. The friction seems fine, I think. Let's see. Do I display the player speed somewhere? No, let's do that. Where do I do that? Debug, print. This is the camera position. Oh, here, this is the player. Output, debug, player, state. Player position, player velocity. There it is. So let's see, where does it cap? It's not capping. Here, it caps at 9.9 basically. That's a little bit too fast. Yeah. See, now it caps at 1.9. That's a little bit too slow. So 3.2 something. Is that okay? This kind of seems a little bit too slow. So .9, I guess. Yeah. This seems fine, I think. Okay. I think this is nice. But now I have to increase the jumping speed so I can jump over 2 tiles. Jumping speed. That's not enough. Still not enough. There it is. It's barely enough. Let's increase it a little bit more. yeah, this feels nice. So the next step is adjusting the wall sliding speed. I think I'm also gonna do that based on friction. If I do that based on friction, I need to store the friction values, the coefficients somewhere. So if every tile has its own friction value, or every tile type at least has its own friction value, it's complicating how these game tiles are stored. I would have do I? Actually, so the game tiles also use this voxel collection. So this range of frames refers to this array of frames. So the hero animations and the voxels, the tiles, use the same underlying structure. So the hero, which is also a voxel grid, as are the tiles. So they use the same structure. I could just have the friction stored here. Which makes sense for tiles, but doesn't make so much sense for the player. Unless I also want the player to have different friction values. No, that doesn't make sense. So instead of storing it here, I'm gonna create a new structure just for tile, for the tile set. Do I use the voxel collection directly for the tile set currently? Yeah, the voxel collection is used directly. Instead, I'm gonna do it like this. Then I can have an array of tile infos. This array should be as long or as big as the frames in the voxel collection. So each frame will have its own friction value. So basically every single tile has its own friction value this way. And then here, instead of having a voxel collection, I have a tile set. That complicates the way I save and load tile sets though. Can I do that a little bit differently? I already have a frame info structure here, which only is being used sporadically. I could just add it here. Okay, let's do the easy way. Let's do it like this first, and then if I'm unhappy with it, I can change it. So for now, I'm just I guess it's fine. For now, I'm just gonna do as if I'm actually loading them from the file, even though I'm not. Texture mapping. I'm just gonna set the friction coefficients to 1 for now. Or 0 is more correct actually. 1 would mean I'm sticking to the wall like glue. So if it's 0, that should mean I need to do this. 0 initialize the destination info. So the friction values should be valid. I'm loading something that doesn't exist yet, which is fine. It's not gonna set this value if this field in the JSON doesn't exist. So it's gonna stay 0. Next thing is I actually need to use that friction value when I'm processing the collidables. So I need access to the tile set. I changed my mind again. Right, let's see. We are gonna do it like this. Yeah, we're gonna do both actually. Tile set, the voxel collection. So this becomes a tile set, and then you're gonna have a different load tile set function. I'm just gonna copy out the friction values into the infos array. So that's the idea here. Locator, tile info. The count is voxels, frame infos dot size. Like this. So we have a bunch of errors now, which makes sense because we're not calling load tile set currently. It's not a member of tile info. Tile info. So this becomes load tile set. Do I use this anywhere? No, I don't. Let's get rid of this. I should call this tile set. Okay, let's make sure that we didn't break anything. Great, everything is in place. But now I can pass in the tile infos. So the collidable component also needs a wall slide friction coefficient because collidable components are also the moving platforms. So they also need a friction coefficient, just like the tiles have. So these moving platforms here that look like the hero, they are also collidable components, and I can also wall jump off of these or wall slide. So they also need a wall slide coefficient. And that wall slide coefficient is on top of the air friction. So if I compile this, it's not gonna work. Does the room store its tile set? It doesn't. It should. Should it? It's easier if it does. This doesn't know what a tile set is. That's fine. Struct tile set. Okay, so now the process collidables function as access to the friction values. So we only need to apply them. For that, I also need to keep track of which tile we are sliding against, just as we are keeping track of which which tile we are standing on. Yeah. So where do I set the, oh, it's just called collision. So this is the collidable we collided against, and this variable only gets set if we are currently wall sliding. This is very clear wall sliding. And this is very reset wall sliding. And then over here where we apply the frictions, we are just gonna check if we are wall sliding, if the wall slide collidable exists. I need a helper function to get the friction. Let's see, collidable ref. Get friction coefficient from collidable ref. Needs a list of dynamics, which is the list of moving platforms, and a list of tile infos. So if let's switch ref type collidable ref is here. If we are sliding against a tile, we want to return infos ref index dot friction coefficient. If we are sliding against dynamic, against a moving platform, we return this value. If it's none, we return 0 and the invalid default case. And then here we can then do this should be on top of a default, I think, default wall slide friction coefficient. Wall slide friction coefficient. So basically the friction that's stored in the tileset infos is a value between 0 and 1. And I basically say how much of the predefined wall slide friction coefficient I'm applying. So this makes it easier to change the wall slide friction coefficient later, even though I already have my assets fixed. So tile info is defined later. Oh yeah. All right, let's pull that up. There are only 5 tiles, but ref index is 16. Ref type is tile, which is correct. Index 16. Oh, this index refers to something else. It refers to the tile grid. Get friction coefficient, so tile grid being a grid of game tiles How do I know what the current frame is? I guess it doesn't matter. Frames, yeah. This doesn't know what tile grid is. Tile grid, let's pull these also up. What's the collection here? Are we triggering this function at any point? Yes, we are. It's a tile, and then we return zero, which is correct. So the default friction value should be 1 then for tiles. Load voxel collection. Okay, let's... So 0.1 seems to be a little bit too little. Let's try 0.5. Does this do something? Friction is still 0. Oh, wait, no. They're all 0. So the problem is earlier. The problem is here. So this didn't do anything. So we set it to 1. And then it gets set to 0. What does the serialize do? It uses get float. Get float has a default argument of 0. That's why. Let's write it differently. So if this value doesn't exist, get float is gonna return 1. So I can get rid of this part. Maybe not. Let's see. Does this do what I wanted it to do? Yeah, it is 1. Yeah, and then now the wall sliding speed is very slow. And there is a bug. If I stop wall sliding, I'm still falling very slowly. Let's see, 0.5 is too much, 0.1. Seems reasonable. So this is a regular falling speed, this is the wall sliding speed. Okay, doing it this way though, making it friction based means it takes a while before the player gets slowed down when starting the wall slide. So if I'm falling very fast, yeah, it takes a while for me to get slowed down. I don't know if that's the behavior I want. That needs some playtesting. There's the glitch again. Okay. The wall sliding speed seems fine. Let's fix that bug. That's not the bug. Oh, right here. Entry. That's not it either. That didn't work. It's because of the search direction thing. Means the search direction. Okay. What happened here? Okay. That's a different bug. That assertion was just in there to see whether that actually ever triggers, and it seems it does. Now there's a different bug. If I'm wall sliding even though I'm not, I don't keep pressing left. So once I start wall sliding, it just keeps wall sliding on its own, even though I'm not pressing anything. That wasn't the behavior before. That's because I'm not doing this. So if the wall jump window ran out, I want to... That's not it. Maybe that's not such a bad thing that it keeps wall sliding. I think in Mega Man it's also the way where it keeps wall sliding once you start without you having to move against the wall all the time. It's just I implemented it accidentally. Why isn't it resetting? Control system. It has something to do with this part, I guess. Wait, if I remove this. Now it doesn't keep wall sliding. And the problem is I'm resetting the wall jump duration here. I think that's why. Yeah, that's why. So the wall jump window, this value here is supposed to be an input buffer. So once I start wall sliding, there's a 10 frame window for me to execute a wall jump. But once I stop pressing moving towards the wall sliding collidable. This window is gonna start decreasing. So after 10 frames, once I initiate a slide, after 10 frames it stops sliding. So that's supposed to make wall jumping easier, where you jump to the left. Okay. Wall sliding will behave like a toggle, not requiring holding the button down. Okay, that's something to think about. I think currently I want it to behave like a toggle just to try it out. I'm gonna take a short break, around 5 minutes. See you in 5 minutes. Alright, I'm back. One thing I want to change here is if I'm wall sliding directly, it also hinders my speed upwards. I only want to limit the wall sliding speed when I'm falling, not when I'm rising. So let's go here. Only if you are moving down. Yeah, that's the idea here. Let's see if it worked. Yeah. Now I have the same jumping height as if I was jumping normally, even when wall sliding. Good. Wall sliding speed is kinda low. Let's increase it. Let's see. Game constants. Yeah, this seems better. But doing this actually means it's gonna take even longer for the wall slide to slow you down. Fast access. Why don't you use scripting language to avoid recompiling when you just want to change player speeds? Scripting language just for that is kinda overkill, since recompilation currently just takes 2 seconds. I wouldn't gain much, but I would gain the overhead of using a scripting language, basically. If you want to change things dynamically, I mean, you shouldn't have to use a scripting language just to be able to switch things dynamically. The scripting language is more like Widget is almost as fast as plain C. No, I didn't mean speed as in compilation speed. I meant like look at how much you need to. Where's the lower part? This. How big is this? Yeah, it's a lot that you have to bind into your code base. This is basically bigger than my game. It's run speed. Yeah, for scripting languages, I don't care about run speed that much, since I'm not gonna do anything complicated in scripting languages. As long as it's not like incredibly terrible. I guess what's the worst one? Oh, so as long as it's not JavaScript, I guess you should be fine. Like even GML, there are lots of games that are coded in GML. Wait, what isn't this game maker language? Oh, it isn't. It's something else. All right, never mind then. Well, scripting languages is if you want dynamic behavior from your game, like being able to mod, or if you already have the binary and you want to change things then. So in that case, scripting languages are useful. But if I already have the power to recompile, I don't need scripting languages. That would be overkill. And some things are easier with scripting languages, but then again, I'm not there yet where scripting languages would be useful. Oh, did I close it? Sorry. Let me bookmark this. Might be useful for later when or if I want to use scripting languages. I guess LuaJIT is fast, but I don't like Lua. C. What is this one? C and 4 functions. Interesting. How big is this? Wait, is it really C and 4 functions? Wow. This is unreadable. Interesting. Well, good to know. Okay, so now we have wall sliding. Or wall sliding speed, which is capped at some point using friction. That friction only gets applied when we are moving down, not up. Okay. Next, I think I'm gonna add a simple particle system. So when wall sliding, I want to have a particle effect at the feet here. So we're gonna spawn particles. And I want position, velocity. This should be enough for now. First we try to get this to work and then think about additional features. Particles. So first we need to allocate the storage for the particles. Like this. Then call this function. So this should compile, but currently it's not doing anything. So what I want to do is should I do it here? I want to do something like if entry is wall. If we are currently wall sliding, I want to emit particles. Entry feet. Dust particles. Then I want to emit one particle using a particle system at the position. I want to emit particles at this position. This is a particle type and 1. I want to do something like this. So this would be feet position. So currently there isn't anything like feet position. I don't have access to particle system since we are not passing it in. So I don't know if this is the place to put it, since this is called in the collision detection code and shouldn't be emitting particles while detecting collisions. So instead, let's leave it in line in the game code for now. And then think about where to put it. So where do I do collision detection here? I'm just gonna calculate the feet position inline for now. Feed position, dust. Let's not think about that for now. So we need the emit particles function. Which takes a position and then count. First I need to cap this. So we don't add too many. We don't exceed the capacity of the particles array. So these are the added particles. We set the position. Velocity is gonna be 0 for now. This should work. Let's compile. Not quite. No matching all loaded function. You? Oh, of course, yeah. This is supposed to be make range view. Particle system is not game state, particle system. Particle, oh, particle system. I have a typo there, alright. And then we need to render the particles. Does this work? Not quite. Entries. This is particles. Right, this seems to work. We are not seeing any particles now. And that's because I'm rendering them at the wrong position. Why am I emitting particles in this case? That's weird. Oh, the moving platform is generating the particles, I think. So I also need to check variable components. The movement type. Yeah. All right. So particles aren't moving currently. Since we are not assigning a velocity and also we are not processing the particles. So now they're moving upwards, but they're never disappearing. let's say they are alive for 200 frames. And then I need to check if entry.alive is less than or equal to 0, in which case we delete it. Which means I need to rewrite this for loop. Okay, now we're iterating over the particles and erasing particles if they're not alive anymore. Let's see if it's working. Yeah, 200 frames seems to be way too long. So 60 frames is a second. Yeah. Let's say they're only alive for 1 second. Now I'm generating way too many particles. Basically, every frame I'm emitting a particle. So there should be a downtime. Before I do that, I want to fix the coloring, so they should get more and more invisible. Okay, let's render particles over here. That's supposed to happen. Let's write a function for that. So this one moves over here. This becomes particles system, particles. Okay, so game to screen is a lambda function. That's actually a useful function. Let's move that out. To here, I guess. Static. Don't care about static. Vector F, game to screen. The Z ordering is wrong. Less opaque particles can be rendered in front of opaque particles, I guess. I could disable depth testing. Yeah, when rendering particles. Set render state. This should return the old state. Should it? I'm not storing render state, so I can't actually do that. Also, this is supposed to be here. So let's do it this way. Render state type test. Alright, now it's correct. So the next issue is I don't want to emit particles every frame. So we're gonna have a particle group that has actually, what's the best way to do that? Another thing is this value here. I need to store the inverse alive because the alive value changes each frame, but I need to know how what the initial alive value was, so I can set the alpha accordingly. Otherwise, this calculation here doesn't work out. Let's see, I shouldn't have broken anything. Yeah, it seems to be fine. I seem to be calculating the feet position wrong. Feet position. These, oops. Position, these need to be the other way around. Yeah, no, the particles are actually at the feet position. So let's make the particles smaller. Something like this. Interesting. The first particle is at the wrong place. Interesting. The wall slide state gets set before the phase direction. How does that happen? That happens because I'm processing the control system first, which sets the phase direction, but this sets the wall slide state. Thanks, Mr. Frenick. Okay, there is a problem. No, it worked. How did this... There it was. Yeah, the first frame where we start wall sliding is wrong. The problem is here. I think phase direction, yeah, this sets the phase direction, but we detect wall sliding in this function. I could do something hacky here. Down here I could do entry wall jump window. I could do this. This is gonna fix the problem, I think. No, I made it worse. These are the other way around. That's weird. Now I can't reproduce the problem. So this particle over here, the misplaced particle, now it only happens sporadically. That's not a good sign. There it was. Okay, I'm gonna try input recordings and see if I can trigger it. There it was. All right. So the problem is at frame 95. So I'm gonna go to frame 94 and pause. Looks like the issue is when you jump from one direction and then turn quickly before wall sliding. Yeah, seems like it. So let's see what this piece of code does. So I'm gonna step. So the wall jump window is 0. I'm not wall sliding. So I'm not wall sliding. And then I am. The face direction should be left. I'm setting it to right. Yeah, thanks. Without a system like this, tracking these kind of bugs down is really hard. What's the problem there? So my face direction gets set in the wrong way. And then it's interesting. And then I'm not wall sliding. Then I'm wall sliding again. So I'm detecting a wall slide prematurely. Okay. So let's play back the recording here while I try to tackle the problem down. So the problem seems to be so down if I remove this again. The problem is still there. So I think in addition to this being a problem, I think I'm setting the wall slide this here I shouldn't be setting the wall slide collidable if I wasn't already sliding. And the premature thing is gone. So it was at frame 95. Yeah, it's gone now. This part of the code is supposed to check whether we are still wall sliding, but it's not supposed to start wall sliding. And I was here, this part of the code was starting the wall slide, and this fixed it. And this fixes, so can I now do this? Let's see. No, the face direction is wrong for a single frame if I at frame 98 if I uncomment this. So let's put it back in. So frame 98. Yeah, now the problem is gone. So adjust face direction if we are wall sliding. Okay, so we fixed 2 bugs in 1. Doesn't really make sense to emit particles if the feet are below the tile. So I could do something. Where do I emit particles? Let's see. Emit particles here. excitable ref. I could check if the feet are below the tile, and if they are, we're gonna readjust the feet position to where the tile ends. Could you talk about how you're able to record and playback gameplay, and does your engine allow for hot reloading? Yes, I can do hot reloading. Both of the things you asked for are done in the platform layer. So the game inputs, let's see, it's is it here? Inputs? No. So my game inputs are just, is a structure. This is the structure for the game inputs. It's just an array for each key, and I'm just storing the key state in this structure. And for input recording, all I'm doing is each frame I am copying out this the game inputs. I'm copying the game inputs for that specific frame into a game recording array. So this is the total recording, and each frame I'm capturing the state of the inputs. And then replaying, I'm, instead of capturing the current frame of the keyboard, I'm just overwriting the keyboard state with the state of the recorded frame. And then I pass in that input state to the game. So the game thinks I just pressed those keys, but in reality they are recorded key presses. So the gameplay layer has no idea that I'm replaying anything. It just runs the game. And hot reloading is done by having the game in a DLL, in a separate DLL, so I can unload and reload the DLL at runtime. So to get the bounce from the thing we are colliding against, I need to do something like this because we might be colliding against a moving platform. I can show it. So I can also wall slide against a moving platform, and the structure of a moving platform is in a different place than where the tiles are stored. So here I need to decide in which array to look to get the bounce. Don't I have a position from index? Coordinates from index. Coordinates from index. Index being ref index. render tiles. So where do I render tiles? Where am I getting the tile rect? Oh, I'm not, those are meshes, yeah, that's right. I can do it like this. Wait, isn't this wrong? Tile width. These are supposed to be these values. Cannot convert from floats. Oh, yeah. Okay. X. So I need to calculate the position of the tile from its position. I mean, the bounds of the tile from its position, which is this here, tile width, tile height, for the dynamic case I can just do result equals dynamics def index dot ab. Actually, get absolute. I should have something called get absolute bounds, don't I? Bounds. I don't, okay. Translate. So we are going to translate the axis aligned bounding box by the position of the moving platform, and that's the result. And then when we are emitting the particles, dynamic entries, name room, let's see, room, layers, the main layer, suppose we collidable system. Cannot convert. Okay, dot grid. Alright, let's hope that fixes it. I think we have more bugs now. Yeah. The wall sliding wall tile is the tile we collided against first. So that's why the particles jump. So we fix this bug. Yeah, we are not generating particles after we are not generating particles at the feet if the tile is above the feet, but yeah, no, these cases are problematic. So first of all, I shouldn't be generating particles at all. If the feet are below. Otherwise, I'm just generating particles on top of each other all the time. And this for the second problem. For the second problem, let's see. I could do another round of collision checking at the feet to see if there is a wall to the right of the feet. I think that is the better solution here. Which means I need this function get next collision, which is a lambda function. I need to pull this out from here. The static keyboard isn't doing anything. I could just get rid of them. So collision info. Does this return collision info? Set collision versus tile grid. Collision result, not collision info. Collision results. Get the next collision. I should call this find collision. So find collision. Basically this function. And it's doing this. didn't change anything, that's good. So emit particles down here. So instead of doing this, we're gonna do find collision. We need the collidable component, the velocity. Velocity is the same thing as down here. This guy. Search through. Velocity, the tile grid. The target region. Region. What next? Dynamics. Okay. Collidable system. Dynamic entries. Max T is 1. Dynamics false. Okay. Instead of doing this, then we just check if the collision, if there is a collision at feet and the t value is less than 1 pixel, something like that. Okay, this compiles. Let's see if it made a mistake. Okay, these particles shouldn't be generated. And the problem is the bounding box of the entry. I don't want to check the player bounding box. Against the wall, I want to check the feet only against the wall, so that's what's the problem. I think. Let's see. Nope. Now it's not doing anything at all. So the old bounding box is this. Oh yeah, I also need to adjust the position. I think. Okay, there it is. So we are not generating particles at the gap anymore. The reason why there was a gap there is because I hit the particle limits. There can only be 200 particles live at once. Yeah, and I'm currently generating a particle each frame, so we're hitting 200 very quickly here. Alright, this is looking pretty nice, I think. So today we did the animations for the player. We've implemented friction, so wall sliding is slower than falling. We also added air friction, so there is a maximum velocity, a terminal velocity when falling.